All right, let me try another video solution. This looks like it might be a short one. Let me see here. It's number 13. It says, what is the magnitude and the direction of the electric field that balances the weight of A, an electron, and then B, a proton? Okay, so I guess I'll start with A, and we have an electron. Maybe I'll just do a little E here. We know that its weight would be pulling down mg. So in order to balance it, we need an electrical force upward. Now, there's two parts to this question. Well, there's a and a B for electron and proton. But again, there's two parts to each of those, which it says what's its magnitude and direction. Let me start with direction, because the point of this chapter was to say that the electric field is used to make the force on a charge. So the electric field times the charge gives you the force. So I'll say if Q is positive, then the force and electric field are in the same direction. Because you would have, let's say this is up, you multiply by positive. Okay, so in other words, positive times a positive still leaves you with a positive. Okay, but if Q is negative, then F and E, the electric field, are in opposite directions. Okay? And again, you can see that in the math that, let's say the electric field is up, so positive y, and then you multiply by a negative number, that gives you a negative y over here. So we want our force to be up, so that means our electric field should be down. So for A, I would have to say the direction of the electric field is going to have some value, E naught, it's going to be in the minus j hat direction. Or if you just want to say the direction is down, direction is down. Okay, well, and as long as we're doing that much, let me jump to B and say, well, let's look at the proton. So if I put a little P with a plus, again, gravity is pulling it down. In order to balance its weight, we want the force on the proton to be up. Again, using the same logic here, that if we're talking about a positive charge for the proton, the direction of the force and the electric field are in the same direction. So in this case, the direction is up. Or if you like, it is in the plus j hat direction. All right, so there's the easier of the two parts. What is the direction of the electric field? Let's go on to magnitude. So taking this and our balancing effect, that if it's a balancing, we want the magnitude of the force on the electron to equal its weight. Okay, because we want the net force, so the sum of all the forces in the y direction, to be 0. Got to balance it. Okay, so the magnitude is QE, and that has to equal to mg. And so the strength of the electric field would be an mg over q. So for the electron, the mass is 9.11 times 10 to the negative 31 kilograms. G is 9.8 meters per second squared. And the charge of the electron, now the magnitude of the charge, I should have emphasized that, I'm said here magnitude, 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 magnitude. So magnitude gives me magnitude. I already did directions. Okay, and so I'm going to go 1.602 times 10 to the negative 19 coulombs. Notice I did not put a negative for the charge of the electron since I'm dealing with magnitude here. Okay, so my units would be in the top a Newton and per Coulomb, which is perfect. Those are the units for the electric field. Actually, they are one of 3 type of units we will see for the electric field. This is the first one, and the only one we've seen so far. Okay, so grabbing my calculator here, 9.11 times 10 to the negative 31 for its mass, times 9.8 divided by 1.602 times 10 to the negative 19. And we're looking at 5.57 times 10 to the negative 11 for the magnitude. And then B, that same logic, so I'm just going to say magnitude of the electric field, so going through these same 3 steps, would be mg over q, and again, this would be magnitude, although in this case, proton, everything's positive. 1.67 times 10 to the negative 27 kilograms for the mass of the proton. 9.8 meters per second squared for G, and the charge is the same magnitude. This time it's a proton, so it's positive, so I really don't need the absolute values there, but just to make it complete, and again pointing out that the units would still be that same basic idea, that it would be a Newton in the top and coulombs in the bottom, so newtons per coulomb. And in fact, maybe I'll just save myself a couple of keystrokes and just go to re-enter, and only have to change the beginning. 1.67 times 10 to the negative 27. Everything else should be the same. And so this comes out to be 1.02 times 10 to the negative 17 newtons per coulomb. Yay! All right, good. That wasn't too long. Hopefully that helped. Bye.